Alright, so here we are with Chapter 5, Section 5. We're talking about the law of sines. So the law of sines is this proportion that's given. And so the idea is that if you know an angle measure of A, and then its opposite side length, A, lowercase a, then that proportion would equal any of these other relations. So you could know angle B and its side B, or angle C and its side C, and of course one of those would be missing so that you could solve the proportion. So, taking a look at an example here, we're going to solve the triangle and given two angles and a side. So, anytime that it means solve, or says solve, that means find all missing variables. So for instance, in this one, we don't have angle C, so we need that. We don't have side length B or side length C, so we need to figure out all of those pieces. So, to start out, I do have side A and angle A and side A. So I am going to be able to use the proportion of sine of 36 over 8 when I solve any of these. So the next piece is I can't use sine of C and C because both of those are unknowns. I need a proportion that will actually match up. So in this case, I have sine of 48, but then over the length of side B, which I don't know. So again, I can't use side C or angle C because those are both unknowns, versus angle B and side B, one of them was known and the other wasn't. So, in order to solve, we're going to cross multiply. And so we're going to get sine of 36 times B equals 8 sines of 48. And so in degree mode, we can evaluate sine of 36 and sine of 48. Alright, and so what mode am I in? Yep. Alright, so sine of 36 is going to be 0.5878, and of course you want to use as many decimals as possible. And then sine of 48, 0.7431. So in order to find B, I need to multiply that 0.74 times 8 to evaluate, and so I get 5.9452, and that equals 0.5878 times B, but then we divide by 0.5878, and we end up with a B of 5.9452. Then, in moving on, we can find angle C. We can find angle C in the more traditional way, and so we can say that 180 degrees minus the 36 degrees and the 48 degrees that we know is going to leave us with angle C. And so we have 96 degrees there. And then we can do the same proportion to solve, but in this case we're solving for B. So we're going to set up the proportion of sine of 36 over 8, and the fact that that's going to equal sine of 96 over C. And so if we solve that and cross multiply, we get 8 times sine of 96 equals C times sine of 36. And so we divide both sides by sine of 36. And we'd get our C value. So let's see, 8 times sine of 96 divided by sine of 36 is going to leave us with a C of 13.5359. So those are our missing pieces when it says to solve. Alright. Then in our next one, we're going to solve again. So we're trying to find all of our missing pieces. We only have one angle this time, which is totally fine. So now we're going to do, let's see, sine of 26.3, and then that's going to be in a fraction with 7. And then that's going to be set up with 6 and b. So for instance, sine of angle b over 6, because we're missing angle b. We're also missing angle c, and then also the measurement of side c. So we can go ahead and find the measure of angle b. So the measure of angle b will come from multiplying across. So sine of 26.3 times 6 equals 7 times the sine of b. Divide both sides by 7, and we get sine of b equal to sine of 26.3 times 6 divided by 7. So we have 0.3798. And then to solve, because we have sine, we need to do sine inverse to cancel out the sine. So if we do sine inverse of both sides, the sines cancel and we're left with b. And then sine inverse of that previous decimal leaves us with 22.3198. So angle b is 22.32. And so then to get our missing angle measure c, we're going to do 180 minus 26.3 minus 22.32. And when we do that subtraction, we'll get the measure of angle c. And so that subtraction becomes 131.38 degrees. And so then in order to solve for side c, we're going to do again the sine of 26.3 over 7, but we'll set that equal to the sine of 131.38 over c. Then we cross multiply. So 7 times sine of 131.38 equals c times sine of 26.3. And so if we divide both sides by 6, oh, that's a c. If we divide both sides by sine of 26.3, we're going to end up with the length of c. So 7 times sine of 131.31 divided by sine of 26.3. And so our c is 11.8673, or 11.87. Right, now I'd like to bring your attention to a few things in this problem, because as we can see in this problem, you are given, let's see, 2 side lengths and an angle, and that angle is attached to the shorter length of the side. And so I'm going to, let's see, where am I going to write it? Right here. So side adjacent to given angle. And the fact that that is smaller or less than the side opposite to the given angle. Because of that happening, there's only one solution. The next one, however, has 2 solutions. We call this an ambiguous case. And so because of that, what happens is that the angle stays stationary, but this side that attached to it is longer than the one that's over here. And so it actually can swing in and make a second triangle that still has an angle of 30, still has a side length of 7, but now has that side of 6 that has swung in. Okay, so we'll kind of put that in here. So you end up getting an obtuse triangle where you could have had an acute triangle. And again, what does that mean for our cases? That means when the adjacent side is bigger than the opposite side, you get 2 cases. Alright, so first thing we're going to do is set up our proportions. So in both of them, no matter what you have your sine of 30 and the opposite side is 6. Even if it's here, because the opposite side is still here. So we still have sine of 30 degrees and in proportion with side length of 6. Then for that top triangle there, let's say that we want to find angle B, so here, its opposite side is 7. So I'm going to set it up and find sine of B, we don't know what B is, in proportion to 7. And then we're going to solve. So we cross multiply, and we get sine of 30 times 7 equals 6 times sine of B. And so we divide both sides by 6. So let's see, sine of 30 times 7, and then divided by 6 is 0.583. And then, of course, I'll take the sine inverse of both sides to get B by itself. So that's 35.69. Okay. So, in order to get angle C, we would then subtract 180, and we know that one of the angles is 30, and the other is 35.69. And so, angle C is minus 35.69, 114.31. All right. So the next one here, finding the height of a pole. Don't know why that's still there. So we're going to find the height of this electrical pole here, because a road slopes 10 degrees above the horizontal. So that's what this piece is here. And a vertical telephone pole stands beside the road. The angle of elevation from the sun is 62 degrees, and the pole casts a 14.5 foot shadow. So that's this piece here. And downhill along the road. And we need to find the height of the telephone pole, so we don't know what A is. Alright, so this idea of the 10 degrees here, this angle is 62. and that is the height of the pole. I feel like I've been cutting out a little bit, so I'm going to just reiterate what happened in these last two problems here. So, because the adjacent side, which is this one, 7 to the angle there, is larger than the opposite side, once we did our first solving with the two pieces given of angle A and side A, and a proportion of the ones that we don't know, so 7 we do, but angle B across from it we don't. When we solve that, we end up with an angle B of 35.69. We can continue with angle B of 35.69 and get C by subtracting from 180, and then setting up a proportion again to get our side length. Or, because we have angle B, we can now get our alternate case, which comes from the supplement of angle B, so 35.69. Its supplement is 144. And again, visually, looking at what we have here, this angle initially was an acute angle, and so that was 35.69. But this angle down here is clearly obtuse, and that one is going to be the 144.31, the supplement. And then from there, you can set up, you can subtract from 180 to find the other C angle, because again, that one changes. It used to be obtuse, and now it's acute. They kind of switch roles. And then you can solve for side length C, which of course is going to be a lot shorter, because now it's just between A and B over here, versus A and B over here was larger than over here. Then in the next one here, just again in case you missed some of those pieces, let's see, we had 62 degrees here, which made a vertical angle with 62 degrees over here. We then had this angle measure here found by saying, oh, well, we have 62 and 90 from that flagpole meeting the horizon, or telephone pole. And then that missing angle measure, which we found to be 28. So then for some reason, because I just wanted to, I solved and got side C, which I've called this one here, to be 30.4166, and then realized that it didn't really matter. This is a right angle with the road, but remember that the road is at a slant of 10 degrees, so if we add 10 degrees to the 90 that's perpendicular to the road, we get this blue angle down here as 100 degrees. And so then when we set up, we know that our one angle measure is 100, our other angle measure is 28, and so 52 is the missing angle that is across from the side we want, which is the height of the pole. So we take sine of 28 over 14.5, because that was in the original problem, and then sine of 52, the angle we're looking for, over D, which we're calling this side over here, and solve to get the height in feet of the pole. So we do have an assignment that uses this, and again, you're always checking at the beginning for that ambiguous case, where the adjacent side is bigger than the opposite side. That would be the one where you need two answers, versus the adjacent side is less than, and that would only give you one triangle's measures. Alright, so there you are.